Good day, guys. Welcome back to the King Theory class, and welcome to another series under the King series. In today's series, we'll be looking at partial fraction. Now, for partial fraction, we'll be looking at one example on board today. And why one example? Because for partial fraction, if you follow through the video that I did on partial fraction, you notice that there are 5 laws or 5 basic rules you need to know to solve literally any question in partial fraction. And then the first one is this representation here on board. That is when your numerator is bigger than your denominator in terms of their highest power. So for the numerator, the variable with the highest power here is 3. For the denominator, the variable with the highest power here is 2. That's the first one. The second law is when your numerator is the same as your denominator. That's the power. Alright? There are things we're going to do when you have such representations on board or in your book. So, and then the third is when your numerator is smaller than your denominator. What am I going to do in that instance? The fourth is when you have a non-factorizable denominator. And the fourth is when you have, the denominator of a particular form, which I'll be showing you in each of these series and with each questions in each of these series. So stay back and enjoy your time here. So for this first question, when you have a question under partial fraction that the numerator's highest power, is bigger than the denominator's highest power, what I'll first do is to say what? Divide using long division method. Alright? So where this is your dividend, this is your divisor. Alright? And I'm going to have it as what? X squared plus x minus 2 all into x cubed plus x squared plus 4x. Alright? So remember again, this is your dividend, this is your divisor, this is your quotient, then whatever you're going to be having, either 0 or any value, negative or positive, fraction or any, is your remainder. So I have a formula which we have as what? Quotient times divisor plus remainder gives me my what? Dividend. Alright? Remember that formula. So quotient times divisor plus remainder gives me my what? My dividend. And at this point, what will I have? Let's divide. Remember, I'm dividing with this highest power of x, all true. X squared in x cubed remains what? X. That is x cubed over x squared. When they cancel out, it remains x on top. X times all these values here, I'm going to have what? X cubed plus x squared minus 2x, alright? So that's x times x squared, x times x, that's x squared, x times minus 2 minus 2x. So on subtracting, what happens? This positive sign changes to negative, positive sign here changes to negative, negative sign here changes to what? Positive, which now becomes my new signs. On adding, this is 0, this also is 0, then this 4x plus 2x is what? 6x. Right? At this point, x squared can no longer go in 6x. Why? Because 6x divided by x squared, I'm going to have a fraction with x as the denominator. So I'm going to stop here. So automatically, my remainder is what? 6x. My dividend remains the same. My divisor, alright, is what? Is still x squared plus x minus 2. Alright, the quotient is x. Is what? Is x. Now, what I will now do to resolve into partial fraction from here is to say remainder over divisor plus my quotient is the formula I'm going to use. Let me reiterate. From the beginning, when you have a partial fraction of the form such that your numerator's highest power is bigger than the denominator's highest power, you must first divide using long division method. That is the law. That is the law. After dividing and getting your answers, you're going to have a remainder. Alright? It might be 0. Alright? So the formula I'm going to do or to apply to resolve into partial fraction now is to say what? Remainder over divisor plus what? Quotient. So let's go on. Right? Arranging it, all I have. My remainder is what? 6x. My divisor is what? X squared plus x minus 2. Then plus my quotient is what? Is x. At this point, I can now solve using, resolve into partial fraction. Now, I'll come back to this. Let me start with this. So it implies that what? This polynomial, this partial fraction, partial fraction is also the same thing as what? All this here. 6x over x squared plus x minus 2, then plus what? Plus x. Resolving partial fraction is to say factorize this denominator. That's for this particular one. Alright? Factorize this denominator and separate using your constants a to z, capital letters. So factorizing this, all I have. If I say x minus 1 all squared, all I have, I'm going to have what? X squared minus what? Minus 2x, then plus 2. So this is quite different. So factorizing, what will I add to get what? 1, and multiply to get what? Minus 2. 2 minus 1. That now will work. So it means I'm going to have x plus 2 and what? X minus 1. Just to confirm is to say what? X times x, x squared. X times minus 1, minus x. 2 times x, 2x. 2 times minus 1, minus 2. Alright? So this is what? X squared. Common terms. Minus x plus 2x is what? Plus x. Then minus 2. Simple. So after factorizing this, I got this. So let's now rearrange. It means 6x over what? X squared plus x minus 2 alone, I'll come back to this, is equals to what? A over what? This first one, x plus 2 plus b over what? X minus 1. Now, at this point, let's factorize this partial fraction. So, multiply, I'm going to have what? 6x to be equals to a into x minus 1 plus b into what? X plus 2. For you to do all this now, you have to watch my video that I posted for partial fraction. I'll drop the link in the description below. So, expand now. When x equals to 1, alright, cover up method. When x equals to 1, alright, what happens? 6 into 1 is equals to what? A into 0 plus b into what? 3. 1 minus 1 is 0, 1 plus 2 is 3. So automatically 6 is equals to 3b. It implies that my b equals to 2. Finally, when x equals to minus 2, that is, equate this one to 0 to know what x will be, so you can eliminate this one. Equate this one to 0 to know what x will be, so you can eliminate this one. That is cover up method. There are two methods on that partial fraction here. So watch the video, then come back to see the solution. So when x equals to minus 2, automatically I'm going to have what? 6 into minus 2 equals to a into what? Minus 3 plus b into 0. Why? Minus 2 minus 1, minus 3, minus 2 plus 2, 0. Automatically, minus 12 equals to minus 3a. Dividing a equals to what? Plus 4. Finally, 6x over what? X squared plus x minus 2 all equals to what? Or let's write the whole equation now. From here, plus x all equals to what? A now is what? 4 over x plus 2. Then b, this is plus. B is what? 2 over what? X minus 1. Finally, again, I've gotten my a and b. Let me now put it back into this equation. What I'll do there is now say what? 6x over all this equals to a is what? 4 over this, b is this over this. But because the total equation, from expansion from the top gave me this, so I have to resolve this into partial fraction. Whenever you are solving a equation that looks like this, you have to resolve this, your remainder over quotient, into partial fraction. Then at the end, add it to this one, and you can solve there. So, this now becomes this plus x, then equals to only this in partial fraction gives me this, then what remains? Plus what? Plus x. As simple as that. So in my next video, I'll be doing the second, I'll be treating a question, using the second law. See you in my next class.